Thanks a lot for coming. I appreciate you guys all being here. We'll just jump into it. My name is Isaac Semro. I'm here from Madison, Wisconsin. I'm a senior designer for Sub-Zero, focusing on new product development, wire harnessing specifically. I'm a designer, technical writer. I've got experience in a variety of industries, including agriculture, heavy equipment, mining, and of course, kitchen appliances. I like to do some DIY stuff at home, whether it's working on the house or car or boat. I like to tackle stuff on my own. I really enjoy cooking, grilling, and smoking for family and friends, entertaining, and then a warm climate traveler. Being from the frozen tundra, we like to escape this time of year and go somewhere warm for a week. So just got back from Costa Rica, and it would be nice to still be there. Session agenda, I'm going to do a little Sub-Zero intro. I'm going to talk about our legacy process. I'll do a quick system overview of one of our fridges. Then we'll talk about Real Route with Solidworks Electrical. Real Route is a term that I came up with, so if you hear the Solidworks guys using it, let me know. Tips and tricks, and then a little marketing video at the end. So Sub-Zero history. After experimenting with refrigeration in the 1930s, Westy Bakke started working with architect Frank Lloyd Wright on some of his one-of-a-kind homes. In 1945, he launched the Sub-Zero Freezer Company. In the 50s and 60s, Sub-Zero pioneers the dual refrigeration system where you're separating the freezer and the refrigerator. And the phrase Sub-Zero kitchen is kind of shorthand for a home that gets everything right. In the 70s and 80s, we lead the way in designing for energy efficiency and superior temperature control. In the 90s, the development of special hinges and panels introduces the disappearing refrigerator design, which integrates it into the surrounding cabinetry. In 2000, Sub-Zero acquires the residential side of Wolf, a legend in commercial kitchens, two specialists, now corporate companions and kitchen soulmates. Throughout the 2000s, Sub-Zero and Wolf lead the way in innovation and performance, launching a full range of products that elevate the kitchen and other areas of the home. In 2018, we were on a mission to conquer clean. We launched our newest brand, Cove, which sets a new standard in luxury dishwashing. In 2020, under its third generation of family ownership, Sub-Zero celebrated 75 years of industry-leading innovation in design. Today, the company's focus continues to be constant, and that is to provide best-in-class luxury appliances that inspire moments worth savoring in the home. So I'm sure some of you may have heard of our products, seen them out and about. Maybe you have one of our products, but if you're watching Netflix or movies, TV shows, we really show up quite often in a variety of venues. In fact, last night when I was watching TV, just before I fell asleep, there's a new Target commercial that's out. And in the background there, you can see one of our classics. So the legacy process, before Solidworks Electrical. So I didn't go all the way back. Of course, there was a time when we're drawing schematics, with a pencil and paper. I didn't go that far back. So our basic legacy process is the engineer draws a schematic, whether that be Visio, AutoCAD, SolidWorks 2D. The engineer would sit down with a designer, then they would place components in the 3D assembly. The designer creates a 3D sketch based on that component placement. And then each sketch segment is measured by the designer, documented by the engineer, and that'll give them like breakout locations for each of the connectors. The engineer uses the measurements to develop tables, including the actual wire lengths, typically handwritten. The designer hand draws a sketch of the wire harness layout based on the 3D sketch that they did and the engineer's input. And then a drafter would develop the detailed drawing using the designer's sketch and the engineer's wire tables and such. So it could take, we're talking weeks, really. Some struggles with the legacy process. We had struggles with first builds, a lot of different revisions. You might have dimensions flip-flopping, a lot of rework, and reworking a wire harness is typically not a lot of fun. So there was no connection between the schematics and the tables or the wire harness CAD, and you'd be manually checking all this stuff, the pinouts and all your connections, and then any changes to that in the schematic, now you're manually updating that in your wire table or cut list. We had minimal 3D in the top level assemblies, maybe some connectors and wire retention clips, but there was no true space claim. And then you're not really able to check for interference. It was just, like straight lines out into space, just to gather all the connectors and such. And then our drawings, they're just dumb drawings, minimal 3D models. The way we were doing it, there was really no scale to the drawings. So again, you're manually populating the bombs, you're manually generating, the wire tables and all that jazz. Manual revisions as well, kind of as I just mentioned, if you're making any kind of a change to the schematic, you need to follow that all the way downstream and make that manual change. I was talking a little bit about how our wire harness drawings didn't really have any scale. In that middle image, you can see those highlighted dimensions. They're all different lengths, 8 inches, 7 inches, 3 inches, 4 inches, but visually they kind of look the same. So it's a little weird if you're not used to it. And then on the bottom, that last image with the highlighted numbers, those are all part numbers that somebody's got to key in the legacy process. This is a system overview of our 48-inch Pro unit. It just kind of highlights the electrical system. So a system overview, what are we hooking up to? Up on top, the unit area, we've got compressors, condenser, inverters, main control board, power supply, water filter, water valves. The freezer, you've got door switches, evaporator and fan, typically an ice maker, LED lights, thermistors, and a UIM. Pretty much the same on the refrigerator side, except we've also got an air purifier and fans. So now we're getting into working with Solidworks Electrical. One scheme does it all. This is something that we just have rolled out. We've done it on one product in this manner, and it's working pretty well so far. So what you're seeing in the background, that gray box represents our main control board, and then that would be all the connections off of it. And then each box above and below it represents a location, which is of course a wire harness. We're able to do this because we use the dynamic connectors, so you don't have to have like all 12 pins of your connector next to each other. You can split them up, and that helps to just give like a real clean, streamlined look, not like a typical schematic where you've got lines crossing all over. And then we'll use the same schematic to create our wiring diagram package for service, which is something that goes along with every product. It's an actual printed wiring diagram for the service folks. Seamless connection from the 2D schematic to the 3D model to the 2D drawing. This is something we love. The engineer inserts the connector into the schematic, and then he's adding the manufacturer parts that's shown up in the top image there. You're adding, your connectors, your terminals, your cavity plugs, any accessories that you might have. And then after the engineer finishes the schematic, the designer is going to essentially highlight, one of those locations, and that location has everything, all the information needed to go ahead and start creating the wire harness. The designer will then open it up in SolidWorks Mechanical, and maybe you're adding your reference geometry, anything else that you need to route it. And then the designer, the way we were doing it, we were inserting the tables from SolidWorks Electrical. If you're familiar with the electrical, there's a ton of reports you can export. I mean, there's a lot. Now what we're doing, we've got it set up where we insert the tables right from SolidWorks. We don't have to do the export from SolidWorks Electrical. So that's, this kind of just illustrates that the engineer is just building the BOM, right, in SolidWorks Electrical, just dragging and dropping components. And then all that information, it just feeds all the way down, so there's no keying it in. Detail drawings. So on the left, you're going to see our legacy. On the right, you're going to see a real route flattened harness. I mean, the one on the right, Super clean, pretty straightforward. We use manufactured. Then it's like a 1-to-1 scale. It's like you would lay it out if you were going to inspect it maybe. Or honestly, it's probably how they manufacture it as well. So suppliers like it a lot better. So some advantages of real route. Some design advantages, it gives the other teams visibility of wire harness routing paths and space claims. And this is really helpful in new product development. So you're not thinking, oh, this is just a wide open space. The harnesses, the controls and such take up space, and it's good for everybody to know that on the front end. It avoids adding just in case lengths that add material cost and can lead to installation issues. I mentioned earlier, like flip-flopping dimensions. When you're developing in this, you see it, you know that the lengths they're dead on, right? It's if you want to move your spline a little bit to make a branch a little longer, you can do that, and it's dead on, so you don't have to add that just in case length. Quick and accurate flat pattern creation. This gets better and better every year. It used to be kind of tedious to create your flat pattern. Now it's pretty easy. Bombs and wire tables generated from the schematic, I kind of mentioned that already, and accurate wire lengths. We don't put the wire lengths on our drawings. We just give them the length of the harness and let the supplier, decide what they need to get that length. It is super helpful though if you're going to maybe build a couple prototype harnesses in-house, to give to your shop guys. Some opportunities to improve. For us personally, I think it's hindered by PLM, but the workflow results in new 3D CAD for revisions. So if you're familiar with Solidworks Electrical, it's all done in a SQL database, I believe. So at some point you need to get your CAD out of there so you can put it into your PLM or your PDM. So you can imagine next time you need to go into that database, maybe to make a small electrical change, the two they're disconnected, right? So you check out your models and then you're overwriting them. Minor changes to a formed wire harness typically require the flattened route to be deleted and recreated. I think they're working on that, but it's just something to keep in mind. And then this is just kind of a personal thing. I'd like to get to as installed pigtails for components, because we still have some components where you get the model from the supplier and it's just like it's like a 4-inch straight out pigtail with a connector on the end. We'd like to get all our components modeled so, it looks just as it would as it's built. Some manufacturing advantages with the detailed visibility of the wire harness routing early. The MEs can provide input to facilitate the design direction. They can help identify and avoid potential installation issues by seeing the CAD. And then you can use the existing CAD for training and accurate work instructions. Some simulation advantages, if you can imagine the wire harness bundle being true to size and routed in its actual position. It's a more precise representation that's kind of beneficial to all simulations. A couple examples, if you can imagine the bundle being in an airflow path, or for us in a foam path, you might change the route of it or something based on that. The winding road to a flat harness. So the formed harness on the left, the flat harness on the right. There's folks that have been working on our Solidworks Electrical journey that have now retired. It's been a long process, and I just decided not to go into the details because it doesn't really matter, right? Like, we've gotten over these hurdles so it can be easier for everyone else. Just some quick tips and tricks. Avoid adjustments to the auto-routed splines unless necessary. So on the right there, you can see there's a wire tie and then all those little fingers going off. So from the wire tie to each of the connectors is an auto-routed spline. You just pick 2 points, boom, it puts it in. Well, if you ever have to make changes or redo your route, you don't want to have to remake all these little adjustments, right? So if it looks pretty good, just leave the auto-routed spline as is. One thing that I like to do is when I get a harness, kind of like, oh, this is good to go, we're gonna roll with this for a bit. I'll save it as a part file. So then if we're going to do another iteration or something, I've got that part file just to lay on top of it. So any splines that I have adjusted, you can, it's tedious, but that's what you have to do if you want the same route. The edit wires function is really awesome. You can verify the integrity of your connections. You can do some troubleshooting with it. You can make repairs after you interrupt your route segment, say with like a spline or coverings. Just use the edit wires function and get you back on track again. Be sure to check out the splice workflow if you haven't already. If you use splices and you struggle with splices, let's just talk after this or something. I don't have the video. It's actually a Solidworks video, but I can get you in touch and get you that video and you won't struggle with splices anymore. Flatten with straight lines only. That's that little image on the left. So you're clicking that box, create flat route with lines only. It's a time saver. And then I already mentioned this, but save your assembly, your wire harness assembly as a part file. You can keep it outside of PDM or in whatever. And like I said, it's great to compare your changes. This video, I'm sure you can find it online. It's just a real nice marketing video that shows off our products. All of you should leave here and order a full kitchen of Sub-Zero Wolf and Cove. So again, thank you for coming. I encourage you to attend the Volcon Go Engineer session. That's a good one. Splicing the gap. Reach out to your VAR if you have questions on how to proceed with SolidWorks Electrical. Join your local user group, and if there isn't one already, maybe create an electrical one. Stick to your established workflows, and if you need to, change them, but don't skip steps. Right? We've got internal APs. And somebody will be working on it, and if you skip a step, it's just not going to work out, right? So they get confused, and I get confused, and it's just a waste of time. So stick to your workflows, change them if needed. Record your sessions, not all of them, but if you're doing something new or something you want to show other people, just record your sessions. I use Snagit, take a lot of screenshots, and it's good for documentation and training. Again, it's a journey. It's not just a project like, hey, we're going to do this SolidWorks electrical project. We're going to switch, and next month we'll be switched over. It's not really like that. You have to have some patience, and it's a bit of a journey. But now is a great time to start if you haven't yet. Yeah, get on board. Thank you all.